So let's put our hands together for the first keynote session of the day. I want to invite Mohamed back onto the stage with the one and only Mo Elshenawy, the CTO and president of Cruise, so they can have a fireside chat about creating new gold standards for autonomous vehicles. Can we give them a warm welcome? Let's hear it for them. Woo.
This is working. All right, good. Well, first session of the day, thank you all for tolerating me and Demetrius here, trying to wake everybody up before we get started. Well, let's get started here. Well, first time we're meeting and talking in front of everybody. Everybody wants to hear from you, so that's a lot of pressure relieved off of me. So let's get started here. Mo, you lead the development of one of the most influential products in our time. Can you give us an overview of your background, how you started, and how you got all the way to here?
Well, first, great to be here. Thanks for having me. It's a long journey, so I'm not going to bore the audience with that. I think the key highlights, which is relevant to this conference, is actually growing up, I was very intrigued by the AI winters. I don't know how many people here read about that, but I read a lot about the first AI winter. I'm not that old, but I just read about that. I was intrigued by the fact that the neural nets can't solve an XOR problem. Let's throw this thing out. And then lived through the second one. That led me to engineering. I had electric engineering and computer engineering degrees. Worked through a long career of being an IC for a very long time on purpose. I really wanted to build a solid foundation. Worked in small and big techs. Founded my own startups, but always did it on the side next to a full-time job. So I have some startup experience and work in big and small companies. And that led me to this amazing mission we're on right now at Cruise, where I've joined them about 6 years ago, and currently I'm president and CTO.
I've known you for years, Mo, and I know that you, in your career, I have a whole thing planned, but this is just on your background. I keep thinking about how you get started into getting into from an engineer into leadership roles, and how you got into now leading thousands of engineers and products. You're leading the entire product division, engineering division at Cruise. How was the transition for you? I know you didn't want to get into, you wanted to stay in the IC role to solidify your technical experience more. How was the transition? Why did you decide to stay a little bit more in the IC side and then jump into the leadership side?
Great question. First of all, I really loved what I was doing at the time, right? I think being an IC is one of the greatest things in the world. You put your headphones on, you don't have to deal with anyone, and I stayed in that track till I became principal engineer, wrote millions of lines of code. I enjoyed it, and frankly, at the time, there was many moments where I was like, is this the right choice? Because you see everyone else jumping early on in leadership track, and in hindsight, I'm so glad, right? I don't regret that at all. It gives you the depth you need to really do your job well as a leader. So without that knowledge, you can't relate, you can't have empathy towards the problems, the real problems that engineers are solving. So I think that served me very well. So I'm glad I did that.
And I can relate to that, but now that we have warmed up, let's address the elephant in the room. The AV space has been one of the most challenging, as we all know. Safety and reliability expectations are very, very high when human lives are involved. Last year, we know that Cruise faced some challenges in San Francisco with a pedestrian incident, and I know that you have suspended your operations voluntarily for other cities as well. Can you share your experience, in your perspective, what happened there and what Cruise is doing to address safety concerns in moving forward?
Yeah, sure. Thanks for asking that. First and foremost, a very tragic incident. Our hearts are still with the pedestrian involved. And I think it's important, this is at the heart of this conference actually, it's important to maybe scroll back in time a little bit without getting into too much details about Cruise and understand the previous philosophy that we've operated under, right? Because at the end of the day, you are what you measure. And at Cruise, we were very focused on something that sounded very reasonable at the time, which is if you have a fleet of AVs in a certain city, and that aggregate performance of such fleet is actually better than the average rideshare human driver in the same city, on average, on aggregate, then you're doing an incremental benefit to that society, and then you should be good, right? Again, sounded reasonable at the time. The reality is that's not what communities expect from robots or AVs. It's not what city officials expect. It's not what the regulators expect, and that was a miss. And that's why when we paused and reflected, we really wanted to come back, and now we are back in 3 cities. I don't know if you're following. But come back with a different philosophy, because again, you are what you measure. So what we're measuring now is not just average and aggregates, because those are very deceiving, right? And we're measuring ourselves against multiple scenarios of driving, almost every category of driving, and comparing ourselves to more of a role model driver, not just an average human rideshare driver. And that's very close to what people expect from us. And we're also taking a very different approach, because now we're thinking about our customers as everyone in the community, the city officials, the regulators, not just people in our cars. So our coming back approach was based on that. That's why it took the time it took to get back into these cities and really build trust. So again, in hindsight, makes a lot of sense. I think we all are in the same boat, myself included. I sometimes get stuck behind a delivery truck or someone bringing an order, and I feel for them. I don't even like honk or anything. Everyone waits patiently. You see accidents around the city and they register in your brain differently. For AVs, it's very different. You expect different, right? And everything you see from an AV, it's the same car. It's like you think it's the same person. So that average and aggregation doesn't work quite as well.
Yeah, that makes total sense. And I heard you talk about the new measuring philosophy, right? And then one thing you mentioned now is setting up a new standard for what is a role model or perfect driving look like. So I'm assuming that I'm just thinking about how this will be executed. Because it makes sense that better than the average driver, you're looking at, okay, setting up the perfect driver. So is this, do you have your team that is thinking like an operations team that is driving and deciding, okay, this is what is the perfect way to respond to specific incidents? So it seems like you are driving this new quality standards for the entire AV industry. How are you going about it?
Yeah, it took a while to even define what that performance bar that we're going to measure, right? What is an attentive, compliant, and unimpaired human driver would do in every situation? And every domain is different, right? For driving, it's not necessarily binary, right? It's not like you're behind a double parked vehicle, for example. What is nominal driving in this case, right? How frequently or how close you can take it over, and it took a while for us, and we're still in this process defining that standards, but we're very confident that, again, that combined with the approach of how we're approaching the regulators and the general public and the communities and city officials seems like the right path for us.
Well, that brings us to the topic of the day here. I heard you before saying you are what you measure. So with this, how do you define, let's start with the AI quality, right? How do you define AI quality?
Okay, well,
I know I borrowed one of your lines in my...
That's a very hard, open-ended question. And the engineers in everyone's mind will be like, okay, it's accuracy, precision recall, F1 scores, pick your pick, right? There's a lot of measures that would define an AI model quality. But I think that's just the start. I think it's a profound question. And to me, I think, to simplify it, I think about it in 2 dimensions. The first one is like, how does your AI model stand the test of time? And standing the test of time means, is it as reliable and consistent across time, even when it sees data it never meant before? So generalization is a very important measure, in my opinion, for AI quality, reliability and consistency. Like, how do you deal with operation constraints, whether it's the size of data you're dealing with or latency requirement? That's one dimension, right? The test of time. Like, you can have a great AI model based on your validation data set right now, but is it going to be great on the field 6 months from now? That's a very important part. And the other part is actually a big topic, I guess, for today is like, how are you doing it in the first place? And the explainability of it, right? And the ethics and fairness part of it as well, because that's usually ignored. That's a very important dimension as well.
That aligns a lot with, and one of the talks I was watching preparing for this, and you mentioned that the new measurement philosophy or the new quality philosophy. One is, you mentioned it now, is setting a new standard for what is a perfect driving would look like, and then the other one is changing the measurement philosophy from aggregate measurements on these metrics into specific metrics or specific measurements for the scenarios, or what we like to call testing scenarios or testing cases. How do you, is this what, how, because I remember you talked about this and then setting up the infrastructure that allows you to, which we'll get to it later, allows to mine for that. So at Cruise now, do you set up scenarios, I'm assuming like test cases, and this is how you're validating? Is this the, what I'm trying to say is like, what is the, how are you testing your models right now?
How are we testing? I will admit, first of all, AV testing, in my opinion, in our opinion, is as hard, if not harder, than developing AV technology. It really is, right? It's a very open-ended question. It's, you know, again, it's not a binary thing. There's certain business problems that is very specific. In this case, like, how do you define nominal driving? But more importantly, how would you score that? Because not every test is as simple as pass-fail, especially for non-deterministic AI. I think you all face that problem. When it's non-deterministic or non-categorical, or it's like, how do you grade it, right? So the way we look at it, first, it is an evolving process, to your point. And really, before going through how we test, the most important thing is how you get that feedback loop in every stage of your testing. We take a multi-layered approach. Think of it as multiple safety nets or Swiss cheese approach. And it starts with every engineer working on the features, right? Which I'm sure this group is very, very heavily involved in that. But as people work on a new feature or a new version of their model, they want to know right away what's the impact, right? So that's a very important part of testing, but it's almost like an indication of the direction, but it's not enough at all, not nearly enough. So as things merge on, like, because this is testing on a snapshot, an isolated snapshot, as hundreds of engineers merge their code, that simulation and integration testing is super important, right? To put it in perspective, we run 19 million simulations every month, millions of driving simulations that we're doing. We go through a lot of data to mine and make sure. And it goes, the layers keep going on, right? You go into car hills and hill benches, hardware testing, closed course testing, supervised testing with AVTOs in the car, and then finally driverless. But again, the most important thing is all the feedback loops, right? Your goal, I'm sure this group would agree with me, is to shift things as far left as possible, right? Keep shifting it left, because if you find something in closed course, the first question you should ask is like, why didn't you find that in the integration test? And like, what kind of gaps do you have? Is it scoring, or is it test exposure, or is it the distribution of your tests? That's all part of the problem.
Well, let's shift gears from testing a little bit. We know that Gen AI and AGI now is taking the world by storm. And it's so
what is Gen AI again?
Well,
never heard that term.
That's part of the hallucination here. But we know that everybody's thinking about Gen AI and integrating that. And it's so easy to fall into the trap and think that autonomous vehicles is just perception and networks, object detection kind of work. But what is the landscape? What does the AI landscape look like at Cruise now?
No, that's a great question. Gen AI is getting, it's too much of a hype right now. But we're fortunate, so here's the thing. Cruise is an AI-first company, not by choice, it's by design. Like, you can't solve self-driving by writing heuristics. I mean, there isn't a way to do it, right? So we've always been AI-centric, we've always focused on that, we had our deep networks, and we've evolved with it. And I think a lot of the folks, if they are not in the self-driving field, you think about self-driving or AVs as like, okay, you're trying to solve a problem that I probably can teach my kid how to drive in 2 weeks. What's the big deal, right? The reality is that's not the problem we're solving at all. That's the easiest part of the problem. Like motion planning or control or nonlinear control theory is great and it's a solved problem. Robotics folks are going to be upset to hear that. It's very important, but that's not the real challenge. The real challenge is understanding what happens in the world and getting that perception of what exactly is the scene and what's about to happen, prediction, which is humans are incredibly good at without even spending any effort. Whether you drive or not, you know if you're in the back of a car, what's about to happen in a scene, and if there's someone's gonna cut you off, if this pedestrian is gonna get in the street or not. That is a real important challenge that we're trying to solve, right? So because we're AI first and because we're AI focused and we're very fortunate to have best talent in the world doing this, we really took a pragmatic approach. We don't jump on the bandwagon like when things become hype. So, but having said that, it would be also silly to say like, oh, we're not using the latest and greatest. We are using foundation model and Gen AI.
Oh, I know. If you didn't say it, I will say it. So.
We're actually using foundation model and Gen AIs in three different categories, right? In the way we drive and explain our driving, very important in the way we get data, retrieve data, and also in simulation, right? And I can give a couple of examples for each of those.
Yeah, please.
Okay, so large foundation models, transformer-based, is a thing right now. You probably read about that a million times, and there's different approaches. Our approach is pretty distinct because we believe that we can't and should not ignore the semantics understanding and the embeddings of the word. So we take our understanding given our elaborate sensor suite and take that understanding of the word and using a large foundation model, project others' behavior along with our best plan or best trajectory to navigate a certain complex scene. So that's ongoing right now. Our teams are working on this one. And again, it's unique in the fact that it's bounded in safety and guarded by the physics, the laws of physics and the semantics understanding of the words, which is a bit different than other approaches. But that's our large transformer models. And we also use it for explainability, right? Because if you're in an AV, imagine if you're in an AV and then all of a sudden it pulls over and you're not yet at your drop-off point and you have no idea what's happening, right? So that's actually a very hard problem because the AV knows exactly what it's doing, but it can't explain that in human language. Well, now it can with Gen AI, right? Because we've labeled a lot of complex scene scenarios. It can actually converse with you as like, I'm pulling over for an emergency vehicle coming from behind. And you can say like, well, I don't hear any sirens. And I was like, okay, the lights are on, but there is no sirens. So that's the first category of where we use Gen AI. AI is as good as the data. So actually, the case that we're really interested about is how that helped us retrieve a lot of the data that we're working with.
With the large vision models?
Vision language model specifically is very, very helpful in writing minors that would get you very specific case. So to put it in perspective, we deal with, it varies from stage to another. Right now we deal with about 9 exabytes of data per month that we process. So for engineers, it's incredibly difficult to find a certain scenario to test or augment their data with. But now you can say like, find me someone pushing a stroller, walking a dog, getting close to the AV. And it would get you that, right? So minors is a very good place. But also another thing that we're excited about, we're publishing this paper soon, is finding the unknowns. Like it's very easy to look for something you know, and it's incredibly hard to find something that you don't know, right? So vision language model can help with that because you can extract keywords from the scene and chart the frequency, and then based on that predict if you've seen that a lot or not. And if you haven't seen it a lot, that's an edge case that's worth someone looking at, for example, right? That's another novel application for vision language model on data retrieval.
I can't wait for this paper to come out because from what you said, the AI landscape is on Cruise. One is the conversational AI, understood the interpretability and explainability of why the vehicle is doing what it's doing. Very exciting. Now, finding the unknowns here, it fits a lot into the concept of building a test coverage. I want to understand that I am testing all the scenarios that I need to be looking for. So one thing is searching. You're using that for data mining. You're using large models for data mining. So you search for the knowns and then figuring out the unknowns. I can't wait for this paper. When is it coming out? You said this today?
I'll check and get back to you on that. I don't want to get wrong dates. Soon.
Well, to shift gears into something else, because I remember you talking about the trifecta mission. I don't know if it falls under this question or not, but what gets you excited the most about the AV space? What's happening next? Where is it going?
Well, it for sure is not without bumps in the road, right? But I don't think anything worth doing comes in easy. we're very fortunate. I call it internally, we call this, like, we have a mission that really falls in this trifecta of things that can attract a lot of people and have you actually stand and be resilient through the bumps in the road, right? Because our mission is very real. Like, you can see it touches people's life positively. It would change the face of transportation. And I'm very excited about this. Not only the dimension of safety, extremely important, but there's many other dimensions for affordability and accessibility, equality. That's really important, right? Like, the current transportation modalities is not ideal, and this is a very real thing that was proven. It is happening, it will happen, and it would continue to improve indefinitely and never plateau. That would really change how things and people move around. So that is super, super attractive. Like, that mission is super attractive for us. But it happens to also fall on the very bleeding edge of AI. Like, I cut the previous question short because honestly, I can keep going on. We use Gen AI in simulations. There's a lot of cool things that happen, right? So when you have a great mission that also happens to be on the cutting edge of AI and robotics, that's amazing. And it's a very viable business at the same time, right? It disrupts $1 trillion industry. So all these three things keeps us really motivated, right? We're very fortunate to have a lot of resiliency and a lot of engineers who are super passionate about the mission, who are united together to make this happen and been pushing through the hard times, the good times, the bad times. And I'm super glad that we are now back with a stronger vision and approach towards how we're going to regain the trust. We're testing in 3 different cities, and I'm very excited about the future.
I'm very excited to see autonomous vehicles being used and democratized, if we have to use the term everywhere. But actually seeing it in operations and seeing how our lives are changing and using AI for good. You guys at the forefront of this, at the hardest of the challenges, because these are not just, you're talking about AIs, it has to be AI and safe and accurate and all the good stuff there. Good luck with this. Very excited. Thanks for coming here, Mo. Please give him a clap of applause. Thanks.
Thanks for having me.